A pleasant afternoon, grade 7. Today's discussion will be about Quarter 3, Module 4, Characteristics of Sound. Objectives: be familiar with the characteristics of sound and how it is described using the concepts of wavelength, velocity, and amplitude. At the end of this module, you should be able to 1. Describe the nature of sound. 2. Describe the characteristics of sound using the concepts of wavelength, velocity, and amplitude. And 3. Appreciate the importance of sound in our daily life. What I know. Choose the letter of the best answer. Write the letter of your choice on your answer sheet. See pages 1 to 3 of Quarter 3, Module 4. What's in? Before we proceed with the main topic, let us have a review of waves by doing the following activities. Directions: label the parts of the transverse wave given below. Choose the correct answer from the words opposite the illustration. So part A, let us name the parts of a transverse wave. So let us start with letter A. So what do we call this part? How about letter B? Letter C, letter D, and letter F. So your choices are trough, amplitude, crest, and wavelength. Part B, complete the word to identify the statement being described in the following. Choose the correct answer from the words given below. So your choices are transverse, frequency, amplitude, longitudinal, sound, crest, wavelength, mechanical, wave, trough, and transverse. Number 1. A blank is a periodic disturbance that moves away from a source and carries energy with it. 2. Transverse waves move up and down in patterns that have highest points called blank. 3. The lowest points of a wave is called blank. 4. The height of a crest or trough is called the blank. 5. The distance between any two troughs or crests is called the blank. 6. Blank waves occur when the individual particles of a medium vibrate back and forth in the direction in which the waves travel. 7. Sound is also known as blank wave. 8. Blank is the number of waves that pass a particular point every 1 second. 9. Waves on the surface of water are called blank waves. And number 10, blank waves are example of longitudinal waves. What's new? Activity 1. Humming a tune. Hum your favorite song and place your fingers on your throat. Observe and discuss what you feel. Activity 2. Making a pop gun. Objective: make a loud bang by a pop gun out of a sheet of paper. Materials: sheet of stiff paper 30 centimeters by 40 centimeters, scissors, and ruler. To make a pop gun, here is the procedure. Number 1, fold the longer edges of the paper together. So you fold your paper here. 2, fold the corners into the first fold. So, first corner, second, third, and fourth. 3. Fold the paper in half long the first fold. Then fold it in half again lengthwise. So you do it like this. Number 4. Open out the second fold. So this is the second fold. 5. Fold down the two sharp corners. 6. Fold the paper back along the second fold to make a triangle shape. And 7. Grip the pop gun firmly by the two sharp corners. Flick it down quickly to make a loud sound. Take note, as you perform the two activities, you are able to produce sound. When we talk or make any sounds, our vocal cords vibrate. So what are vocal cords? Vocal cords are two bands of smooth muscle tissue found in the larynx or voice box. So here is our vocal cords. So this is the first muscle tissue, And this is the second muscle tissue. So the vocal cords vibrate and air passes through the cords from the lungs to produce the sound of your voice. When there are no vibrations felt, no sound is produced. So remember, kapag walang vibration, wala ring sound. This means that sounds are caused by vibrations. So the reason why we hear sounds is because of vibrations. Vibrations of molecules are the to and fro or back and forth movement of molecules. So look at this picture, you can see that air molecules are moving to the left and to the right, creating areas of compression and areas of expansion. So sound waves are examples of longitudinal waves. So longitudinal waves, if you still remember from Module 3, the vibration of the particles of the medium is back and forth or to the left and to the right. So sound wave is a longitudinal wave. So sound wave is also known as a mechanical wave since sound waves need medium in order to propagate. So para magkaroon ng sound waves, kailangan natin ng medium at ang medium ng sound wave ay air. No air, there would be no sound. So, kanina, dun sa activity number 2, the pop gun produces a quick and large movement of the air, which formed a sudden and powerful sound wave. So, kaya nagkaroon ng sound doon sa pag-flick natin ng ating pop gun because nagkaroon ng vibration in the air. Sound is about vibrations. If you still remember, in our previous slide, we said that if there's no vibration, then there's no sound. Sound is a disturbance that travels through a medium as a wave. So, kaya nagkakaroon ng sound because we disturb something. So, sound is also an example of a longitudinal wave, meaning our particles of the medium vibrate back and forth. That's why in a sound wave, there are areas of compression, yung mga dikit-dikit na air particles, at meron din mga parts na naka-expand. Next, sound is also known as a mechanical wave, meaning there has to be matter for which sound should travel and propagate. And this matter is better known as medium. And one medium of sound is air. So without air, there would be no sound. That's why in outer space, we cannot hear sound. Sound can travel in solid, liquid, and gas. In module number 3, we discussed that sound can travel in air, and air is a form of gas. So, hindi lang sa gas, pwede mag-travel ang sound. So, pwede rin po siya mag-travel sa solid, at pwede rin po sa liquid, but not in a vacuum. So, hindi pwede mag-travel ang sound sa space without matter. So, in outer space, there is no sound. So sound is more distinct in solids than in air. Ibig sabihin ng more distinct, mas dinig na dinig ang sound kapag ito ay nag-travel sa solid kaysa sa air. So, ang ibig sabihin nito, it also means that sound is heard much louder when it travels in solids than in air. So, isang example na lang, pumalo kayo sa ibabaw ng table ninyo, tapos pumalo kayo sa hangin. So, saan kayo merong naririnig na mas malakas na tunog? So, di ba kapag pinalo nyo yung table? So, pag pinalo ang table, which is solid, mas malakas ang tunog kaysa pag pinalo nyo ang hangin. Ang hangin ay gas. So, solid, as you can see in the picture, the particles of a solid are closely packed to each other. Dikit-dikit ang ating mga particles. So, we call these particles as molecules. So, ang ating solid molecules are closely packed to each other. Tapos, sa liquid naman, medyo loosely packed. Hiwa-hiwalay sila ng konti. Nagkaroon na ng spaces. Okay? And in gases, the molecules of gases are widely separated. So, meron bang kinalaman ang spacing ng mga molecules sa different particles of matter? Kung bakit mas distinct ang sound sa solid kaysa sa liquid or sa gas? So let's find out the answer. So as you can see in figure 1, particles of solids are more closely packed than particles of liquids and gas. So kagaya na in-explain ko kanina sa previous slide, ang molecules ng solid ay dikit-dikit. So kung makikita nyo, ang intermolecular spaces natin ay napaka-liit na nga dahil nga sobra silang dikit-dikit. Pero pagdating sa liquid, ang ating particles of liquid or yung molecules natin ng liquid ay medyo nagkahiwa-hiwalay na at mas lalong hiwa-hiwalay pa pagdating sa gas. This is why sound produced in solid is much more distinct and louder than when it is propagated or produced in liquids and gases. So bakit ba mas malakas ang tunog sa solid? Kasi yung vibration ng isang part ng ating molecules ay madaling na ipapasa sa susunod or sa katabing molecules dahil sila ay magkadikit. So dahil magkakadikit ang mga molecules, the vibration is passed on easily to the next molecules na katabi niya. Hanggang sa yung buong mga molecules natin ay mag-vibrate na. Pero, pagdating dito sa gas, tingnan ninyo, since ang kanilang spaces sa pagitan ng dalawang molecules ay medyo widely separated, medyo magkalayo sila, ang vibration ng isang molecules, gas molecules, ay medyo matagal bago niya maipasa sa susunod na gas particles or sa gas molecules. Kaya, ang sound sa air or sa gas ay hindi masyadong dinig na dinig. Unlike kapag ito ay nag-travel sa solid. So, between liquids and gases naman, so liquid particles appear more closely spaced than gases. So, sa pagitan daw ng liquid and gases, mas dikit-dikit ang molecules ng liquid kaysa sa molecules ng gases. So, ano ibig sabihin nito? Louder sound will be produced in liquids than in gases. Sa pagitan ng liquid at gas, mas malakas ang tunog sa liquid kaysa sa gas. So, bakit ulit? Kasi, kung titignan natin ang molecules ng liquid, mas magkalapit sila kaysa sa molecules ng gas na medyo widely separated. Okay? So, since solid is the best transmitter of sound, sound travels fastest in solid and slowest in gases. So, pinakamabilis na mag-travel ang sound sa solid. Tapos, pinakamabagal siya mag-travel in gases. So, take a look at our example. Steel, ang speed of sound sa steel ay 5,941 meters per second. So, bakit ganun kabilis? Kasi ang molecules ng steel, which is solid, ay dikit-dikit. They are closely packed. That is why, yung vibration ng isang molecules ay madali niyang maipapasa sa mga katabi niyang molecules hanggang sa yung vibration ay nakarating na hanggang dito sa dulo. Tapos, pagdating sa liquid, medyo bumaba ang speed of sound. 1,482 meters per second sa water. So, bakit? Kasi water is liquid. The particles of liquid are loosely packed. Medyo magkakahiwalay sila. Kaya yung vibration, hindi kasing bilis na naitatransfer sa next particles unlike sa solid. At pinakamabagal ang sound pagdating sa air, which is a gas. 343 meters per second. So why? Look at the particles of air. So it is widely separated, hiwa-hiwalay, masyadong malayo sa isa't isa, kaya yung vibration ng isang particle medyo mabagal bago niyang mailipat sa susunod na particles na malapit sa kanya. That is why, ang best transmitter ng sound, pinakamaganda ang transmission ng sound pagdating sa solid. Okay? Tapos, ang poor transmitter of sound, gas. Tapos, sound travels fastest in solid, pinakamabilis sa solid, and slowest or pinakamabagal sa gas. Tapos sa liquid ay average. Sound speed is dependent on three factors: atmospheric pressure, relative humidity, and atmospheric temperature. High values of these elements lead to faster moving sound. Kapag daw ang ating atmospheric pressure, relative humidity and atmospheric temperature ay mataas ang values, ibig sabihin daw nun, ang sound natin ay faster moving or mas mabilis. So, take a look at this picture. So, yung mga dots na nakikita nyo ng kulay white, those represents the molecules in air. Kapag madami ang molecules ng air, kagaya dito sa nasa baba. Okay? So, ibig sabihin nun, the atmospheric pressure is high. So, these molecules contribute to the pressure or weight at this altitude. So, dito sa lower portion ng ating drawing, here we have a high atmospheric pressure. So, if there's high atmospheric pressure, then the speed of sound becomes faster. So, kung makikita nyo, yung mga molecules natin ay medyo madami. Okay? At dahil madami sila, mas madaling mailipat yung vibration from one air molecule to another. Unlike dito sa upper portion, kung saan ang ating air molecules ay lesser or mas konti. So kapag lesser yung air molecules natin, then lesser din ang atmospheric pressure. So dahil lesser ang air molecules, less din yung transfer ng vibration. Okay. Next, number 2, relative humidity. So, 10% relative humidity versus 90% relative humidity. So, mas maraming molecules dito sa part na ito. So, mas madaling mailipat yung vibration from one particle to another. Kaya, faster ang sound. Next, atmospheric temperature. Kapag mataas ang atmospheric temperature, ang air particles ay mas mabilis ang vibration. So kapag mabilis ang vibration, mas mabilis ding maita-transfer yung vibration na yon to another air molecule. Next, did you know? Sound cannot travel in a vacuum. So pag sinabing vacuum, empty space. Remember that sound is a mechanical wave. So dahil ang ating sound ay mechanical wave, it needs a medium in order to propagate. If there is no matter, then there is no sound. In outer space, sound would not be transmitted. So look at this picture. So sumabog na yung kanyang spaceship, pero itong si Mr. Astronaut, di pa niya pansin. Ang mas inintindi pa niya ay yung pagkati ng kanyang likod. So bakit hindi niya napansin na sumabog na pala yung kanyang spaceship? Kasi nakatalikod siya. And hindi niya narinig yung pagsabog because in outer space, there is no matter. Ano ba meron sa outer space? Di space. Okay? Empty space. Wala. Okay? So, if there's no matter, then there's no sound. That's why in outer space, sound would not be transmitted. Next, characteristics of sound. So, before we proceed with the discussion of the characteristics of sound, let us have a recap of the following terms: wavelength, velocity, and amplitude. So, if you still remember, the wavelength of a wave refers to the distance between any successive identical parts of a wave. So for instance, distance from one crest to the next is equal to one full wavelength, or distance from one trough to the next is equal to one full wavelength. So look at this picture. So crest to crest is one wavelength. Trough to trough is also one full wavelength. So, balikan lang din natin. Crest is the highest point of a wave and trough is the lowest point of a wave. So, kapag sinabing wavelength, yun ay crest to crest or trough to trough. Next, we have amplitude. So, amplitude is the maximum displacement of a vibrating particle on either side of its normal position when the wave passes. It is also called as the height of the wave. So, if you will look here, pag sinabi nating amplitude, ito ay crest to normal position. So, yung normal position natin, ito yung origin or ito yung equilibrium. Ito yung ating matter kapag hindi siya dinedisturb. So, crest to normal position or equilibrium is called amplitude. Tapos, pwede rin nating sabihin na trough to normal position or equilibrium is also amplitude. So, dito sa picture na to, meron tayong 1, 2, 3. 3 examples of amplitude. Next, we have velocity. So the velocity of sound is the distance traveled per unit time by a sound wave propagating through a medium. So if you still remember our formula for velocity, velocity equals distance plus direction divided by time. So yan ang ating formula for velocity. So the velocity of sound is 343 meters per second in dry air at normal atmospheric conditions. It can only be changed by altering the medium or the properties of the medium. So para makuha rin natin ang velocity of sound, aside from this formula, we may also use velocity equals wavelength times frequency. So in symbol, a small letter V, this symbol for wavelength times frequency, a small letter f. Next, how do sounds differ? So the clap of thunder may be very loud. Okay, so pag nakarinig kayo ng kulog, so sobrang lakas nun. A whisper may be soft and low. So have you whispered in somebody's ear? A dog's growl is like a deep bass. The sound of a jackhammer is a noise that seems to break the eardrum. Some voices have pleasing quality, while others are harsh or grating. These examples indicates that sounds differ. Each is distinct from the others. Sound may be regarded as fingerprints of the persons or objects producing them. They differ from one another in three ways, namely loudness or intensity, pitch, and letter C, quality. So let us first discuss about loudness and intensity. Intensity of sound is the amount of energy a sound wave carries. So high amplitude carry large amount of energy and have higher intensity. So, ang amplitude, energy, at intensity ay directly proportional sa isa't isa. Anong ibig sabihin nun? Pag mataas ang amplitude, mataas ang energy, at mataas din ang intensity. Let's take a look at this example. So, pag sinabi nating high amplitude, mataas yung height ng ating wave, kagaya dito. So, tinan ninyo yung height mula crest hanggang normal position at mula trough hanggang normal position. So dahil high ang kanyang amplitude, ibig sabihin nito ay high din ang kanyang energy. Pag mataas ang amplitude, mataas ang energy, it is also of higher intensity. Next, punta naman tayo sa low amplitude. If we have a low amplitude sound, it carries less amount of energy and it have a lower intensity. So, sa kabilang example, kung makikita nyo, ang amplitude naman ng wave na to ay medyo low or mababa. Okay? So, from crest to normal position, ang kanyang height ay mababa. Trough to normal position, ang height ay mababa rin. So, if we have low amplitude, then less ang energy nun and lower ang intensity. So, sa pagitan ng dalawang sound wave na to, this sound wave has a higher intensity. Tapos, this sound wave naman has a lower intensity. So, kapag lower ang intensity, low din ang kanyang energy at low din ang kanyang amplitude. Kapag naman high ang intensity ng isang sound wave, high ang kanyang energy at high din ang kanyang amplitude. So, directly proportional ang amplitude, energy, at intensity. Next, the intensity of sound is proportional to the square of the amplitude of sound wave. So, ano ibig sabihin nun? This means that as amplitude of sound becomes doubled, dinoble natin ang amplitude, the loudness of sound becomes quadrupled. So, example, Dito, soft sound. Ang amplitude ng sound wave na to ay ganito lang. Ganyan lang kataas. Tapos pagdating dito ay nadoble. Okay? So kapag nadoble daw ang amplitude ng isang sound wave, yung loudness niya magiging quadrupled. Okay? 4 times ang ilalakas. So next, sound intensity is objective. Pag sinabi nating objective ang sound intensity, ito ay nasusukat. And it is measured by various instruments like the oscilloscope. So this is a picture of an oscilloscope. So this oscilloscope measures sound intensity. So kung makikita nyo dito, merong lumalabas na mga sound waves. So yung sound waves na yan, ang magme-measure if our sound source has a high intensity or a low intensity. So, ang tawag natin dito sa instrument na to ay oscilloscope. Okay? However, the subjective judgment of a person on the intensity of sound is called loudness. So, anong pinagkaiba ng loudness sa intensity? Ang loudness is a psychological sensation that differs for different people. Ang loudness ay subjective. Pag sinabing subjective, depende sa tao. Kanina, diniscuss natin yung sound intensity. Ang sabi natin, ang sound intensity ay objective. Pag sinabing objective, nasusukat. At ang instrument para sukatin ang sound intensity ay oscilloscope. Pagdating naman sa loudness, ito ay subjective. So ano yung subjective? Depende sa taong nakikinig. Merong mga tao na para sa kanila ang tunog na to ay mahina. Pero sa ibang tao naman, malakas na yung tunog na yon. So same lang yung tunog na pinakikinggan nila, pero magkaiba sila ng perception. So kapag perception ng tao ang pinagbabasihan ng tunog, kung ito ay malakas or mahina, ang tawag po natin dito ay loudness. So it's psychological. Okay? A logarithmic scale is used to describe sound intensity, which roughly corresponds to loudness. So, ang sound intensity at loudness ay related sa isa't isa. So, ang sound intensity, objective, nasusukat. Ang loudness naman ay subjective, depende sa taong nakikinig. Loudness is how soft or how intense, how loud the sound is as perceived by the ear and interpreted by the brain. The unit of intensity level for sound is the decibel, symbol small letter D, capital letter B, which was named after Alexander Graham Bell who invented the telephone. So, di ba sabi natin kanina, ang sound intensity objective na susukat. At para sukatin, meron tayong instrument na kung tawagin ay oscilloscope. So, sound intensity is measured in units called decibel. Okay? So, yung decibel is named after Alexander Graham Bell. So, this is that person. So, he is the inventor of the telephone. So, father and son duo interprets the loudness of a sound differently. The son considers the rock music as a soft music, while the father considers it as a loud sound. So the father may even interpret the sound of the electric guitar as a distorted sound, which is also known as noise. So pag sinabi nating noise, it is a wave that is not pleasing to the senses. So pag sinabing noise, ingay. So hindi siya magandang pakinggan, masakit sa tenga. Table number 2, sound levels, description, and examples. First column, range in decibels, description, and examples. So 0 to 30 decibel is described as very quiet. This is the threshold of human hearing up to the sound of a quiet whisper. Next, 31 to 50 decibel is quiet. This is an average quiet house with maybe the sound of a fridge running or someone moving around. 51 to 70, normal, regular daily sounds like people talking. 71 to 90 decibels is loud. This is the point where a sound becomes annoying or distracting. Vacuums or a noisy car on a busy street are at these levels. Next, 91 to 110 decibels, very loud. Most people will try to avoid being in areas this loud. Prolonged exposure can cause permanent ear damage. Temporary effects like stereo hiss may happen. 111 plus decibel is painful. Even limited exposure to levels this high will cause permanent hearing loss. Okay? So, take note of sound levels, description, and examples. Did you know there is danger to hearing loud sounds? So the high intensity sound energy destroy tiny hair cells in the inner ear. These cells slowly wear down, and when depleted, it will never be restored. For this reason, it is important to avoid unnecessary noise. Avoid exposing yourself to places or events that can damage your ear. This is the time to start caring for your ears because the extent of hearing loss becomes fully evident only when you reach old age. So take a look at this picture. This is after concert deafness. So this is what the inner ear hairs looks like before loud noise. So kung mapapansin nyo, yung mga inner ear hairs natin ay nakatayo. So they are very healthy. But after hearing a concert na merong loud music, malalaking mga speakers, this is what happens to our inner ear hairs. So some of them are destroyed. Tapos, if they wear down and when they are depleted, hindi na sila mare-restore. So, it's very important that we avoid this kind of places or events na pwedeng mag-damage sa ear natin. So, guide question number 1. Since the loudness or intensity of sound has something to do with the amplitude of a wave, identify which diagram illustrates a low amplitude and a high amplitude. So, amplitude is the height of the wave. So, letter A, look at the amplitude or the height of the wave. Is it a low amplitude or a high amplitude wave? Letter B, so is this a low amplitude or a high amplitude wave? So let us answer. So letter A is a low amplitude wave. And letter B is a high amplitude wave. So when we say high amplitude, it shows tall or high waves. So kapag high ang amplitude, it means high ang intensity, greater ang energy, loud ang sound, malakas. Kapag naman low ang amplitude ng ating wave, it shows small or short wave. So ibig sabihin ng low amplitude, it has low intensity, low energy, at soft ang sound. Some sounds are low, others are high. The highness or lowness of sound is called pitch, a characteristic determined by our senses. So, sa Tagalog, yung pitch yun yung tinatawag na tinis ng boses or ng tunog. So, sometimes yung pitch ay high, sometimes it's low. And the the factor on which pitch depends is frequency of vibrations of the waves. So, tingnan natin ang waveform ng isang bass guitar as compared sa waveform ng isang whistle. So, this is the waveform of a bass guitar. 1 millisecond duration. And this is the waveform of a whistle. So, anong mapapansin nyo sa frequency of vibration of the waves? So, sino ang mas maraming waves? Yung bang sa bass guitar or sa whistle? So, kung mapapansin niyo, ang waves ng bass guitar ay medyo layo-layo. Okay? Tapos, yung waves na nabuo sa 1 millisecond duration ay konti lang para sa bass guitar. Pero, para naman sa whistle, kung makikita nyo ang waves ay dikit-dikit, at maraming waves na nabuo in 1 millisecond duration. So, anong ibig sabihin nito? So, if the frequency of vibration is higher, we say that the sound is shrill and has a high pitch. On the other hand, if the sound is said to have a lower pitch, then it has a lower frequency of vibration. So, kanina dun sa previous slide na pinakita natin sa bass guitar, kung mapapansin nyo, konti lang yung waves na nabuo sa 1 millisecond duration. So, ibig sabihin nun, ang kanyang frequency ay mababa. Yung frequency ng vibration niya ay lower. So, kapag lower ang frequency of vibration, ibig sabihin nun, low ang pitch. Mababa yung pitch noong sound source natin. Tapos, doon naman sa whistle, okay? So, sa whistle, makikita nyo na yung kanyang waves dikit-dikit, tsaka yung waves na nabuo in 1 millisecond duration ay madami. So, ibig sabihin nito, yung frequency ng vibration para sa whistle ay higher. Okay? So, pag higher ang frequency of vibration, then, yung sound source natin ay merong high pitch. So, let's take a look at this picture. So, yung unang picture natin shows high frequency. Okay? So, kung mapapansin nyo, maraming waves na nabuo sa time duration na nakaspecify dito. Whereas, dito sa pangalawa nating picture, yung waves na nabuo, medyo konti, para sa time duration na nakaspecify dito. Okay? So, pag mas maraming frequency, pag higher ang frequency ng ating waves, so ibig sabihin, ang pitch noong sound source na yon ay high pitch. Tapos naman, kapag low ang frequency of vibration, okay, konti lang yung mga waves na nabuo, then our sound source has a low pitch. So, question number 2. Since the pitch of sound has something to do with the frequency of sound wave, identify which diagram illustrates a low frequency and which illustrates a high frequency. So, letter A. So, is this low frequency or high frequency sound? How about letter B? Is this a low frequency or high frequency sound? So, let's find out the answer. So, letter A is a low frequency sound. And letter B is a high frequency sound. So, pag sinabing high frequency, it shows short wavelength, dikit-dikit yung ating mga waves. So, ibig sabihin kapag high frequency, high ang pitch. So, sound moves fast, mabilis. Waves are close to each other. Kapag naman low frequency, it shows long wavelength. Ibig sabihin, medyo hiwa-hiwalay yung ating waves. Tapos, low ang pitch ng ating wave. So, ibig sabihin din nun, sound moves slow and waves has greater distance. So, in general, high-pitched sound is often unheard to an older person. So, kapag matanda na ang isang tao, yung mga high-pitched sound di na masyadong naririnig than it is to a younger one because as a person gets older, the limits of his hearing range diminishes, causing him to have difficulty hearing sounds at higher frequencies. Next, it is then important for you to understand your parents as they reach this stage and be patient with them. So, di ba minsan meron tayong mga lolo't lola or mga matatandang mga kakilala natin na hindi na makarinig. So, kaya sila hindi na makarinig kasi as they get older, yung kanilang hearing range nagde-diminish. Pabawas ng pabawas yung kaya lang na marinig ng kanilang tenga. Many people are exposed to noise that damages their hearing. So people with hearing loss not able to hear high-pitched sounds. So from 20 to 29 years old, 30 to 39, 40 to 49, 50 to 59, and 60 to 69 years. So as age becomes higher, habang tumatanda ang tao, okay, so mas tumataas yung percentage na hindi na sila nakakarinig ng high-pitched sounds. So at the age of 60 to 69 years old, 68% ng mga taong ganitong edad ay hindi na nakakarinig ng high-pitched sounds. So, bakit nagkakaroon ng loss of hearing? So, kasi yung mga hair cells inside our inner ear ay nadadamage. So, kapag tayo ay na-expose sa mga loud noise, posible na yung ating mga hair cells ay ma-damage. At pag na-damage sila, they can never be replaced. Okay? So this is what happens. Kaya nagkakaroon tayo ng hearing loss. So sound vibrates the eardrum and tiny bones in the ear, which in turn vibrate the hair cells in the inner ear. Exposure to loud noises over time can permanently damage the hair cells, causing hearing loss. So next, quality. So if a piano and violin are played at the same time, at the same pitch, can you distinguish the sound produced by each instrument? So kahit nakapikit, alam natin ang pinagkaiba ng piano at ng violin. Kasi kahit na at the same time and at the same pitch ang kanilang tinutugtog, meron ng kakaiba sa kanila. Okay? So sound quality or timbre distinguishes sound from one another. So we are able to distinguish the sound of a piano from that of a violin because of timbre. So two sounds of the same pitch may not sound the same. So the quality of sound is determined by the velocity of the sound. So nakakaapekto sa quality or timbre ng isang sound source ang velocity. So the unit for velocity is meter per second, and different materials have different velocity. That is why a saxophone, which is made of steel, has a different sound quality compared to a flute, which is made up of wood. So kahit na nakapikit tayo, pag tumugtog ang saxophone at ang flute, we can distinguish the sounds because of their sound quality or timbre. So again, what are the different characteristics of sound that we mentioned in module number 4? First is wavelength. This is the distance between two successive crests or troughs of a wave. It is related to pitch as to frequency, higher pitch. Velocity, speed of the disturbance as it moves through the medium's molecules, not the speed of the molecules. So different materials produces different quality of sound. And then we have amplitude. So this is the maximum displacement of a vibrating particle on either side of its normal position when the wave passes. It is the height of the wave. So amplitude is related to loudness of sound. So high amplitude means loud sound. Low amplitude means low sound. So let us answer the different activities and what's more, independent activity 1. Fill in the missing parts of the given graphic organizer to complete the entire concept of the nature of sound. So sound is about blank. Sound is an example of longitudinal wave. Sound is also known as blank. Sound travels through blank, blank, and gas. Examples, table. Examples for this is water. Examples for gas is carbon dioxide. Independent Assessment 1. Complete the crossword puzzle by filling in a word that fits each clue. So across, sound is also known as blank. A space without matter. 5. Medium in which sound travels faster than gas. 6. A disturbance that travels through a medium as a wave. Down, number 1. Medium in which sound travels slowest. 2. The to and fro or back and forth movement of a molecule. And 6. Medium in which sound travels fastest. Independent Activity 2, Objective. In this activity, you will use sounding box to describe the characteristics of sound. Materials needed, a shoebox, variety of rubber bands, thick and thin, extra cardboard, pair of scissors or cutter, ruler, and a wooden rod. So procedure, cut and design your shoebox as shown in figure 5. So, hanap kayo ng shoebox tapos i-cut nyo like this. Put the rubber bands around the box. Make sure that the rubber bands are almost equally spaced, that the rubber bands are arranged according to increasing thickness from the lower end to the other end of the box. Label the rubber bands of the box as S1, S2, and so on. Labeling should start from the thinnest, pinakamanipis, papunta sa pinakamakapal. So parang gagawa kayo ng gitara mula dun sa shoebox ninyo. Tapos yung magiging strings ng gitara ay yung rubber bands. Next, number 4, pluck each rubber band. Listen to the sound produced. Question 1, so sasagutan nyo to sa inyong answer sheet. What did you observe when you plucked each of the rubber bands? Ano ang na-produce? Q2, is there a difference in the sound produced by each of the rubber bands? So, meron daw bang pinagkaiba ang tunog ng S1 sa S2, sa S3, S4, S5, and S6? Q3, which rubber band produce a higher sound? Saan mas matinis? Which rubber band produce a lower sound? Saan naman daw mas mababa ang tunog? Q4, how can you make a softer sound? So, paano nyo dapat i-pluck? How can you make a louder sound? So, paano dapat i-pluck pag louder sound ang gusto mo? Q5, what factors affect the pitch and loudness of the sound produced by the rubber bands? Ano daw nakaka-apekto sa pitch at sa loudness ng sound ng rubber bands? 5. Stretch one of the rubber bands and while doing so, pluck it again. So, nung in-stretch mo yung rubber bands, Q6, is there a change in the sound produced when you pluck the rubber band while stretching it? Next, procedure 6. Place the ruler on its edge across the box as shown in figure 6. Pluck each rubber band and observe. Is there a difference in the sound produced when the ruler is placed across the box? So, nung nilagay yung ruler doon sa box, tapos pinlock, meron daw bang pagkakaiba sa tunog? And number 7, move the ruler off center to the left or to a diagonal position so that one side of each rubber band is shorter than the other side. See figure 7 for this. So yung ruler medyo ililihis nyo ng ganyan. Pluck again each rubber band on each side of the ruler and observe. So Q8, which part of the rubber band, shorter side or longer side, provides higher pitch, which provides a lower pitch? So, nung tinagilid nyo yung ruler, tas pinlock nyo itong side na to, yung longer side na to, tapos itong shorter side na to, alin daw ang mas higher ang pitch? Alin daw ang mas lower ang pitch? And Q9, again, what factors affect the pitch of the sound produced by the rubber bands? So next, independent assessment 2, answer the following questions. The amplitude is a measure of how tall the wave is. The higher the amplitude, the louder the sound, the higher the intensity, the greater the energy. So answer the following question. Which sound wave has a higher amplitude? A or B? 2. Which sound has a louder sound? A or B? Next, the shorter the wavelength is, the higher the frequency. The closer the waves are together, the higher the frequency. The higher the frequency, the higher the pitch. So question, which sound wave has a higher frequency between C and D? Alin na mas higher ang frequency dito? C or D daw? 4. Which sound wave has a higher pitch between C and D? Next, number 5. Which sound wave has a higher amplitude? E or F? 6. Which sound wave has a louder sound? E or F? 7. Which sound wave are closest together? Yung dikit-dikit ang mga waves. E or F? 8. Which sound waves has higher frequency? E or F? 9. Which sound wave has higher pitch? E or F? And 10, what is the same in sound wave? G, H, and I. Amplitude, frequency. So, alin daw dito ang same or magkamukha lang? G, H, or I? Independent Activity 3, Straw Kazoo Activity. Materials, 3 pieces unused drinking straw, pair of scissors. Procedure number 1, make a kazoo using straw. Flatten one end of the straw by biting down and pulling it out of your mouth while keeping your mouth closed. So, kakagatin yung straw, tapos ipo-pull out of your mouth para ma-flatten yung isang end ng straw. Next, number 2, diagonally cut out the corners of the flattened end of the straw to make a V shape at the end of the straw. So, pagkatapos nyong i-flatten yung isang side ng straw, i-cut nyo na parang letter V. Okay? So, parang may tulis na ganito ang mangyayari. Next 3, blow into the straw, observe what happens. So, pagkatapos nyong igupitin na parang letter V, patulis yung ating straw, mag-blow ka daw sa straw and then observe what happens. Repeat steps 1 to 2 with 2 more straws. Okay? So, uulitin nyo lang yung steps. Tapos, 5, cut the other end of the 2 straws to make 3 different length. Blow into the straw one at a time. Observe the change in pitch as the straw kazoo is shortened. So, answer the following questions. Number 1, what kind of pitch is produced by the longer straw? So, yung mahabang straw, ano ang pitch na na-produce? High or low? Number 2, what kind of pitch is produced by the shorter straw? Yung maiksing straw, ano daw na-produce na pitch? High or low? Next, independent assessment 3, match the characteristics of sound in column A with their characteristics in terms of the given item in column B and their definitions in column C. So, yung column A, hahanapin nyo yung sagot sa column B. Tapos, yung sagot sa column B, hahanapin nyo sa column C. Okay? Next, the Sum It Up Challenge. Let us frame the concept, fill in the blank to complete the statements of the paragraph. So, meron tayo dito mga missing concepts. You are going to write the correct answer for that. Okay, tapos dito kayo mamimili ng sagot. So, ang choices nyo ito, gas, fastest, amplitude, solid, longitudinal, wavelength, loudness or intensity, pitch, frequency, liquid, quality or timbre, vacuum, slowest, vibrations, and medium. So, you have 15 missing words that you need to complete for what I have learned. So, what I can do, you are going to have a jingle making activity. So, take note of the following. 1. Topic will focus on the role of the youth in combating the challenges in the times of COVID-19 pandemic. Create musical instruments from indigenous materials that can be found in your house. Indigenous materials such as sticks, bottles, or glassware available in your locality to be used as musical instruments. So, in short, recycled materials. Use these instruments to compose tunes for your jingle. 4. Use these instruments to serve also as your accompaniment. And 5. Refer to the rubric scoring to guide you in doing the activity. So 6. Jingle must be an original composition, duration 60 seconds or 1 minute. Provide a copy of the lyrics on a separate sheet of paper. Provide an illustration, drawing, or picture of the instruments created. 10. Have it recorded in MP4 format and save. Be ready anytime. You will be asked by your teacher to submit it in any platform suitable for you. So, dito sa what I can do, jingle making activity, so I will leave it up to you if uh, on how you will do this. Okay? So, gawa kayo ng jingle tungkol sa role ninyo bilang kabataan sa paglaban sa COVID-19. Tapos, ang mga musical instruments nyo made from recycled materials, ang jingle or yung kakantahin niyo dapat ay original composition, 1 second lang. 1 minute lang ang duration. So, this will be the rubric scoring. So, ang criteria, improvise, localized musical instrument, theme, singing voice, melody. Next, assessment. Answer the questions on page 19 to 21 of Quarter 3, Module 4. So, additional activity natin. So, medyo madali lang ang ating performance task, 3.4. Draw a happy face. Okay? If the sound described is pleasant. So, pag masarap sa pandinig, yung tunog, draw a happy face. And a sad face if it is unpleasant. So, madali lang to So, may nagpapiano, may bumubulong, tapos yung iba pang mga nakalagay dito. Okay? So, next, quarters 3, module 4, these are the things that you need to have on your answer sheet. Number 1, sagutan ng what I know. Sagutan ng what's more. Please, sagutan ang independent activities 1, 2, 3 and independent assessments 1, 2, 3. So, para mas lalo kayong matuto. Next, answer what I have learned, what I can do, assessment, and the additional activities. So, yung additional activities, yan ang ating performance task number 3.4, quarter 3, module 4. So, if you're done, pass your answer in PDF format sa inyong Google Drive folder or you may submit them in JPEG format to my messenger. So, thank you for attending our Science 7 online class. God bless you all.